And hi, welcome to this video. So in this video, I want to talk about, I want to continue, pick up where I left off, and I want to automate the testing of this cubic solver. So we know the solution should be as follows: minus 3.0489, 1.6920, and 1.3569. Okay. Fortunately or unfortunately, we may or may not have the so-called solutions. We may not have these cubic roots come out in exactly this form, depending on the way we do our algorithm. For the time being, it is okay that it just so happens that the roots of this equation, minus 3.0489, 1.692, so on and so forth, 1.35689, all of these roots come out in a very orderly fashion, exactly the same order as what we see here. However, if these roots were shuffled around, okay, if these roots were shuffled around and say let's say minus 3.0489 came first, 1.3569 came second, and 1.6920 came third, that is an equally valid answer. So we cannot find we should not fault how do you say, if these roots come out in a different order, we should not say that it is a wrong answer. It is indeed a valid answer as well, no matter how these roots are sorted. Okay, so how do we do an automatic comparison such that these roots come out in an orderly fashion, so that no matter what the algorithm behind this find cubic roots function is, how do we make sure that the tests are consistent? Okay, we cannot just okay, let me show you the not so good way of comparing first, right? Okay, so this in this part, I think it's very good for us to sort of familiarize with vectors. It's a very good excuse or reason to introduce ourselves to vectors, since these cubic roots introduce us to vectors in Rust anyhow. Okay, so let's let root 1 equals to a solution. Okay, this is the most primitive way of finding doing accessing elements in the vector. Let root 1, root 2, and root 3 equals the first and second, or first, second, and third element of the solution. Okay, this will of course pass the test, but I still need to do the comparison, right? And I want to do the assert approximate equal, assert relative equals root 0. Root 0 should be minus 3.0489. I'll give it an epsilon of 0.001. Okay, this is the first assert relative equal. And mind you, assert relative equal, you should best practice is to only have one assert relative equal per test. But I'm kind of bending the recommended rules here. This is just something good programming practice, but for now I'm not really caring about it, because all three roots need to be correct in order for this to pass. Okay, so this is a very primitive way of comparing vectors, comparing the elements in a vector. So basically, I am extracting the floats out of these vectors. So root 0, root 1, and root 2, and then I'm comparing them one by one. Okay. 1.3569. Okay, let me change this to root 2. Okay, so this will pass. This will pass. Now, let's say I shift this around. Let's say I shift this around, and then let's say for whatever reason I shift this around, I'm going to get a failed test. Why? Because the roots are not correctly matched against each other. So the third root here, 1.3569, this is not compared very well. It's not compared to the root over here. So this is a very bad way of doing things, of course. I'm showing you the negative example first. So 1.692 is one of the roots, right? Is one of the roots. Unfortunately, root 1 happens to be 1.35689. So that's bad. That is bad. Okay, so I'm comparing two of the roots. I'm comparing the roots. Yes, I'm comparing the expected root, which is 1.692, to one of the other roots. Okay, because there are three roots, I'm not comparing the same root. Okay, 1.35689. Okay, so because the order came up wrong, then this test fails. But this test should not fail because I'm still outputting all three roots, all three of the correct roots, right? This is just because I happen to change the way that the root vector is constructed. Okay, so it's y0, y1, and y2, right? I'll push the solution vector. I'll push the roots into the solution vector using a different sort by sorting it in a different way. Just because I rearrange the order of y1 and y2. Okay, how do we get this test to pass? Okay, of course this way is kind of primitive. We do not want this at all. So let's say let's try this out a different way. Okay, instead of having solution 1 and 2, okay, let me comment this out and say this is a bad way to do comparisons, right? Okay, so what do we do now? Now we recognize that maybe root 0 is minus 3.0489. This happens to be the minimum root of all of these in this solution vector. So how do we get the minimum? Okay, so I want to introduce us to some what do you call that? Some methods to get minimum and maximum value from a vector. So this is one good example you could do it. So let root 0, and this should be the minimum. Okay, root 0 equals to, okay, so solution. Okay, so this solution is a vector. What you can do with vector is you obtain you can get a minimum or maximum of the vector. So you use how do you do it? Is you convert it, sort of borrow it as an iterator. It says returns an iterator over the slice. Okay, but don't need to exactly worry what it is now. You can just find the min as follows. Root 0 equals iter min. And well, we actually run into a problem. Okay, in fact, we run into a few problems. Yeah, we run into a few problems. Okay, it says relative equals is not implemented for option N64. Okay, so why is this so? Because this minimum thing, what's the return type? This return type, it gets option of self item, right? It gets option of self item. So this option is an enum that it needs to be unwrapped, as we saw before. So I have not really taught how to, or rather haven't really gone through how to deal with options. So the easiest way is just to unwrap. Okay, unwrap, and that would sort of get you there. Okay, then what? Okay, so the thing is that with float 64s, this minimum method doesn't quite work. Okay, this minimum method doesn't quite work. So the correct thing to do here is to use the min by method, and then you need to sort of get how to say, put in a little bit more complicated input. Okay, so one of the things is that minimum here requires you have to unwrap the option first. But the second thing now is that since you have a float 64, float 64s do not implement this ordered trait. Okay, this standard comparison odd. This is a trait that helps numbers compare to each other. This is done for integers but not floats. That means floating point decimals. Okay, there is a partial ordering, but we have to use some other different way of getting this how do you say it? Getting the minimum value. Okay, the syntax isn't very intuitive, I must admit, but let's just skip up on that for the time being. We'll use another way of getting the minimum value. Okay, if you're interested, you can skip all of this, but I want to go through how to sort of be comfortable around vectors first before going into those iterator methods. If you really want to do sorting, you can actually just use this sort by, vec.sort by a comma b. Yeah, these two things here, a dot partial CMP, partial comparison, and unwrap. Okay, this will give you the easiest way of sorting. So let me just copy that first. If you're interested if you're interested in the going through vectors, then sure, please continue. But if you want a shortcut, this is the shortcut. I'm not going to go through the shortcut first. Yeah. Okay, so let's go back to the basics so that of working with vectors, so that we can learn how to sort these vectors out. Right? How do you sort these vectors out? All right, so I'm going to do these things first. Let root 0. Oh wait. No need. Okay, I'm going to have this solution here, and let this solution here be, I'm going to call this solution vector, solution vec, because I want to be very clear that this is a vector. Okay, solution vec. All right, so if I want to so-called access every single element in this vector, now the bad way is to go and access the elements one at a time in a very manual fashion. That's not the way to do it. The better way to do it is to use a for loop. And the way to write for loops for vectors or for almost any vector or in Rust, what you can do is this. Okay, for solution in solution vect dot iter. Okay, this is how you write a for loop. Okay, for solution in solution vec dot iter. Do note that and let me comment this out first so that you don't have compiler errors. Okay, for solution in solution vector. Okay, this solution is the element within the solution vector. All right, so this is the generic way you write for loops for vectors. There's more than one way actually to write a for loop for vector. All right, there's more than one way to actually write this for loop, but this is the most basic way. Now, this solution here is actually a reference or a pointer. Okay, this is the NS64 type. So if you actually debug these values, debug the solution values, okay, you can actually print out the output, right? You can actually print out the output of these solutions. So how do you actually print out the debug? I'm going to use the no capture flag. Okay, cargo watch -x test. Okay, -- no capture. This will enable us to print out all the solutions, all the debug functions. Okay, again, cargo watch -x test. You pass in the argument using this double dash space double dash space double dash no capture. That's the syntax. I know it's weird, but that's what it is. Okay, press enter again, and you will see that all the three roots actually come out. So this actually loops through everything in the solution vector. So this is an iterator. So this This is how you do the iteration thingy. So you can actually name this anything you want. You can even call this x. Okay, and this will still work the same way. Okay, it's just that this time we have x equals to minus 3.0489, x equals to 1 point something. Yeah, you kind of see the printing output kind of crosses over here. That's why it's a little bit weird, but it's okay. Yeah, this is definitely okay, because you know the values are still there. It's just that the printing's messed up. Okay, because this test here and this test here is running in parallel. So sometimes when they print at exactly the same time in a very inconvenient fashion, thus resulting in output that looks very funny like this. Okay, if this is an error and you don't want this kind of output, we call this a race condition, but we shall not go there. Okay, we shall not go there. All right, so let me save this, and yeah, this is how we use for loops in iterators. Okay, I want to change this back to solution, of course, because yeah, I want to, yeah, maybe it's not a race condition, but it does look like. Doesn't matter. Okay, so I have the 3 roots here, and yeah, I'm able to access the elements in each vector. So using this very simple for loop, I'm able to get all the numbers out individually, and I can actually code in a maximum or minimum function. Okay, so let's do it this way. Okay, let min value is f64, and instead of minimum value, I'm going to call this minimum root, and this will be called max root. Both of these values will be mutable. Okay, both of these values will be mutable. And what am I going to do? So for the first solution, yeah. Okay, maybe I should not do too many things at one go. Okay, let's just try finding the minimum root. How are we going to find the minimum root using this for loop here? So what I've seen online in some code bases is that you start by you need to assign an initial value to this minimum root, right? Let's say this minimum root is 0.0. Okay, if there is something less than this 0.0, if there's a root less than this one 0.0, then if there's a solution in this solution vector that is less than this 0.0, then we use that solution. So for example, 1.692 is not the minimum root, and 1.692 is greater than 0.0, so we don't do anything. Okay, well, what about this? Minus 3.0489. Minus 3.0489 is less than 0.0, and it just happens to be the minimum root. So if the root minimum root is 3.0489, the tentative minimum root is minus 3.0489, then we will use that to be our minimum root. Okay, maybe the explanation wasn't good. Let me try again. Okay, so let's say we want to find the minimum root in this vector. I'm not going to look at the code. So if this, we know from here, obviously, just by looking, that the minimum root is minus 3.0489. All right, minus 3.0489. So let's just use a random number. Let's say the number 7. If we have the number 7, we compare it to 1.69. Okay, 1.69 is actually smaller than 7. So so far, our minimum root, we first assign the value 7 to it. And then we start going through our solution. We start going through all the elements inside this vector. Okay, let's say the first element is this 1.69, right? Just give some imagination for the time being. Let's say the elements are swapped. Okay. Okay, maybe I'm going too far. Never mind. Forget it. Let's go for the first root again. Okay. Again, let's assume that the first minimum root, the initial value of the minimum root is number 7. If then we go to the first element. Okay, the first element here is minus 3.04. Minus 3.04 is less than 7. So since the value of the root here is less than 7, so the minimum root will not be 7 anymore. It will be minus 3.0489. Then since now we have the root value here is minus 3.0489. We take this value and we compare it to this value right here. Okay, our minimum root now is minus 3.0489, and we compare it to 1.6920. 1.6920 is more than minus 3.0489, so the minimum root is unchanged. Okay, so basically we use a comparison function. Okay, we use a comparison function to cycle through all the values here. The first value being the minimum of minus 3.0489 should be the minimum, right? So yeah, if this is a minus 3.0489, it's the minimum, and yeah, and the initial value we assigned it is 7. Okay, this algorithm works fine. Okay, initial value is 7. We compare 7 with, yeah, this initial value, we give a placeholder value for the minimum root of 7. We compare 7 with minus 3.0489. So the tentative minimum root is now minus 3.0489. So we take the tentative value of minus 3.0489. We compare with 1.6920. We find that minus 3.0489 is still smaller than 1.6920. So we don't need to change the minimum root value. And then of course, since we will need to compare with the last element here, minus 3.0489, we compare it with 1.3569. Again, minus 3.0489 is still the minimum. So we cycled through all the elements in this vector, and we found that minus 3.0489 is the minimum root. Okay, so this is fine so far. However, we have to be very mindful what the initial guess of the minimum root is. Okay, the minimum root we initially guess is 7. 7 is actually greater than all these 3 numbers, which is important because that allows us to compare, to say that, okay, minus 3.0489 is less than 7, so we do the swapping of the values here. Okay, so that's how we find that minimum value. However, if all 3 of these roots are greater than 7, and we use 7 as the initial guess of our minimum root, then this algorithm kind of fails, and we get the minimum root of number 7. Even though, if let's say the roots of the equation are 10, 13, and 15. Okay, if these roots here are 10, 13, and 15, and we use an initial guess for the minimum root of 7, we will still get, based on this algorithm, a minimum root of 7. So we cannot do that. So what we need to do is to make sure that our initial guess for the minimum root is bigger than these 3 numbers here. It is bigger than these 3 numbers here. Okay, the only way to make sure that this is possible in all cases is to use the largest value of f64, so that to use the maximum value of the floating point f64, and we compare these 3 roots against the initial guess. So the initial guess value has to be bigger than all 3 of these roots for the minimum thing to work. Okay, so what I'm going to do is I'm going to do a f64 max. This is a constant. Okay, so this is our initial guess for the minimum root. So this is a very manual way of finding the minimum root. Now, of course, better ways to do it, more elegant methods, but let's go through the basics first. Okay, minimum roots here. Go for solution, and if the solution is smaller than the minimum root, okay, if solution is less than minimum root, then what do we do? Okay, min root equals solution. Okay, we are getting an error here. Why? Because we expected an n f64. This is a reference. We found an s64. Okay, minimum root is a floating point f64 value. Solution is actually a n f64. In other words, a pointer or reference. Okay, I'm not going to make the difference. I'm not going to differentiate what a pointer and reference is yet, but just know that they are different. We will have to come back to this concept of pointers, references, options, and enums. Everything we'll have to come back later. But for now, to make sure both of them are the same, we can just use the ampersand sign. Okay, it says what? Consider borrowing here. Okay, the Rust compiler already helps us to tell us what to do. Okay. So you see, say consider borrowing here. We can just use the solutions from the compiler. So that's why I love this Rust compiler. It's very friendly. Okay, and then it says here, consider dereferencing the borrow. So what? You just put an asterisk in front of the solution. Yeah, you don't even have to know what the borrowing and referencing are. You do this and it is fine. So okay, we have the minimum root over here. Okay, so I'm going to assert minus 3.0489. This has to be the minimum root. Okay, so that is right. This is the minimum root. Okay, minus 3.0489 with the epsilon 0.01. Okay, we can do the same for the maximum root. Okay, using a similar algorithm, but we have to invert it. In the sense that the initial guess for the maximum root must be so small that it's smaller than all these values. Okay. Maximum root. Let mute max root, okay, equals f64 minimum. Use the constant here. And I'm going to use this iterator again to do the for loop. So if the solution is more than the maximum root, then the max root is the solution. Okay, we use that solution to find the max root. So where should the max root be? 1.6920, right? 1.6920. Okay, this will help us to get 2 out of 3 roots already. Okay, so this is just a learning experience to find out how to write simple for loops in Rust for vectors. Okay, we just use this very simple syntax for something in this solution vector. Always use this call it an enumerator or iterator. Okay, and that will help us to get these what do you call that? Get the elements out, the maximum and minimum. So this is a very manual way of doing the maximum and minimum of the whole vector, and that will get us 2 out of 3 roots, which is good. Okay, so now we kind of need to deal with this remaining what do you call that? Remaining a root, which is 1.3569. This is neither minimum nor maximum, so we need another way of finding this out. So let's start using a little bit more advanced stuff. Right, we already covered how to use iterators here to write simple for loops. So that will help you so-called we'll do simple for loops in Rust. Let's get you started. Then the more advanced stuff is over here. Okay, you use this sorting function, and that's a very, what do you say? This is a very convenient and succinct way of writing things. But I mean, you don't really get to learn all of this if you use that method. Now, is there an easier way to do this? Well, I wouldn't say it's easier. It's more of the making your code more concise. You can do the same things. So the way to do it, well, if you look online, Stack Overflow or Reddit, yeah, you can use this this max by sort of a max by method. Okay, method. Now, if you look in lots of what my go-to is just to Google max float Rust vector, something like that. Do a quick Google and you look at Stack Overflow, what actually works. Okay. However, since we already have something in the Rust cookbook, okay, we can actually sort a vector of floats using this vec sort by. Okay, we can use this vec sort by. So how does this work? All right, we have a vector of unsorted elements, so 1.1, 1.15. Yeah, so 1.15, yeah, 1.15, 5.5, 1.123, 2.0. If you do the sort by method, you use this sort by method. Okay, you can just copy and paste this. You'll see that the vector will actually be sorted. Okay, so let's use this to get the maximum and minimum, or in fact sort the vector out, so that we have each and every of our elements there. Okay, so let's use this sort by. We'll clone the vector first. We'll clone this entire vector. Okay, let solution vec clone, and I want to make this mutable equals to solution vector dot clone. Okay, this will make a complete copy. Right, I just want to make a complete copy first, so I don't touch my previous solution. So now I want to sort this solution vector. Solution vector clone sort by. Okay, and we need a comparison, a comparator function. Ooh, yeah, even looking at that, if you are new, yeah, it looks scary. So what you do is just you copy this down here. This is the comparator function. A, B, then you use the partial CMP thingy right there. I'm going to paste this here. I'm not going to really figure out what this is, but this is the comparison function. Okay, now let's debug this thing. Debug this solution vector clone. This is now a sorted vector. Okay, the sorted vector is now sorted by you know the values. So the minimum is indeed minus 3.04891. The middle is 1.35. The final is 1.69. Okay, so if we want the minimum and maximum, it's now a lot easier because we can just take the first and last what do you call it? First and last element. So max root now is equals to the last element, right? So solution vector clone, I can actually use this one called last. Okay, and now unwrap it. Okay. And then of course I need to dereference. Okay, and the minimum root is now the first. Okay, and this thing would actually work just nice. This would actually work just nice. And what I can actually have this here. Let middle root equals to solution vector clone. I will put the middle element. And actually I can put the middle root right here. Okay, so this is a so-called better way. actually, yeah, it's a more concise way of actually sorting your vector to get the minimum and maximum things. So we learned quite a fair bit about dealing with vectors here, right? We learned how to write basic for loops, right? Write basic for loops over here. And of course, we have sorting, an automatic sorting algorithm here. Okay, you do a sorting algorithm here, and this is how you do it. Yeah, if you're not sure, you can hover over it, and yeah, you can either look online or you can actually hover over it to see how this is done. Okay, the partial CMP unwrap. Okay, so this is how you do it. So yeah, the middle root is the number in the middle. You can just get it by index number 1 because it will be well, there are 3 roots, so this is the second root. But since we start at 0, you have to use the index number 1. Okay, so this is how you find the minimum and maximum root. Okay, so I'm going to just comment out these for loops. You don't really need them. Oh, actually, never mind. I will leave it so that there's a reference here to see that there's more than one way of doing things. Okay. So anyway, this last part helps to part is a more elegant solution for sorting the vector and finding min and max roots or values in a vector. So there are many ways to work with vectors. It can get a bit complicated, but just remember, go online, Google, do a bit of Googling, look at the documentation. You should be able to find yourself some answers. And if anything, you can actually just start with a for loop, okay, using this iter method. Okay, those are the very basics of working with vectors in Rust. Okay, so let me copy this and paste this here. And I guess we're done for this video. Okay, thank you.